Okay, so here's the definition of the function that we want to integrate. And it's just basically a sine function that goes through a complete cycle between t equals n minus 1 and t equals n. Now the period of this thing is clearly 1, right? T changes by 1, this changes by 2 pi, which means the sine goes through a complete cycle. Okay? So, what we got then is the t-axis. 0 is here someplace, right? And then you got like 1, 2, 3, and then a little break in the axis because you don't know where the heck this thing is. But here, eventually, you've got n minus 1 and n, right?
We got a resistor right there.
Yeah, that's a no, it's not a resistor. It's a break in the axis. You should be able to tell the difference. A break in the axis looks like this, and a resistor looks like this.
My bad.
Just think about it.
My bad.
Okay.
My bad.
Okay, now, so here's your, there's a thing on the board that's preventing the chalk from moving forward. Okay, it's one of the flaws of these boards. I got to bring a sander in and smooth these out. Anyhow, there's your function, and just to be sure we understand it completely, there's your function. And it goes past the break, and it doesn't do anything till we get here, and then it goes back to 0, right? Get well? Laplace transform of f of t is related to the Laplace transform that you have on the interval from 0 to 1. Okay? And it's just e to the minus n minus 1 s times the Laplace transform of, now it's going to be hard to write this, I'll say Laplace transform of g of t, where g of t is just the same function on the interval from 0 to 1. Okay? And I don't have time to write that down. So this is the formula that we actually derived. Laplace transform of h of t, well, actually, yeah, let me do this. I don't have to call it g of t, because you guys work this out. This is h of t minus h of t plus 1, f of t. Okay? Because h of t minus h of t plus 1 is just 0 between 0 and 1, right? Okay? And then we worked out an identity that gives us this, but it turns out that it occurs to me we don't even really need that identity, but we can still do it. Okay? I'm just going to write the integral. You can work out y. Okay? Because the Laplace transform of this just basically has your sine function between 0 and 1 and 0 every place else, because the difference of these two functions is 0 every place but on the interval from 0 to 1. And it's 1 on that interval. So that reduces it down to just this integral, and that's an easy enough integral to do. Okay? So you get a result here in terms of n and s. Okay? Now we're short on time because I went and digressed about quaternions and all kinds of, and bridge building and strength of materials and all the stuff you guys are going to be dealing with. I'm not going to have to deal with quaternions. What you get then extending this, okay, if you've got a sine function, it's not restricted, it has period 1, okay? On this interval, okay, this thing here,
Right now I have. You too. What's up, man? Good, how are you doing? Hey, I'll message
I'm
you.
going to use my favorite variable to represent this integral, aardvark. Okay? Well, if n is 1, you just get aardvark, right? So this interval contributes an aardvark. I'll abbreviate that as ard. Okay? On this interval, what do you get? You get e. Okay, now n equals 1, right? I'm sorry, n equals 2 on this interval. Okay, because this goes from, the interval goes from n minus 1 to n, right? If n is 2, that means you're going from 2 minus 1 to 2. Okay? So now if n is 2, it's e to the negative s times your aardvark. Okay? Here you're getting e to the negative 2s times, I'm going to use a big A for aardvark, I'm getting tired of writing out all those letters. Okay? Because every time n changes, this, yeah, you get another integer in front of s, and it's a negative. So what you get is Laplace transform of sine of 2 pi t is the sum, well, let's just write it this way. It's 1 plus e to the negative s plus e to the negative 2s times aardvark. Aardvark just being this integral, which you can easily do. Okay? And that equals 1 plus r squared and so forth times aardvark, where r is e to the negative s. Okay? Because e to the negative 2s, for example, is just e to the negative s squared, right? E to the negative 3s would be e to the negative s cubed, and so forth. Well, that's just a geometric series that's equal to 1 over 1 minus r. Okay? So what we get is, and I'm out of room here, but I want to get it on the same board, that result the sum of the geometric series, which is 1 over 1 minus r, times aardvark, and of course r is 1 minus e to the negative s. Okay? So now, in order to get the Laplace transform of the whole blame sine function, we can do the integral on just the interval for one period and multiply it by this, or divide by 1 minus e to the negative s. Assuming I've got the, something seems to be missing there. Yeah, the only thing's missing is a coefficient, because now if the period of the function, and this applies to any periodic function of period 1, okay? If the period is t instead of 1, capital T, then you're just going to have a t down here in a place that's obvious, okay? So there's the trick. Well, this is a Laplace transform of the sine function, the Laplace transform of your alternating step function, okay? Voltage, negative voltage, voltage, negative voltage, periodic, is even simpler because this integral is real simple. It's just an integral of a sum of h or t type functions. So that's what we're leading toward, okay?